Okay, so today we're going to begin Chapter 8. We're going to cover Lesson 1 today, and it's the law of signs. You will need your calculator, and for this chapter, we're going to make sure that our calculator is in degrees. We're going to be using our trig again. Up till now, whenever we did our trig, our sine, cosine, and tangent, it was always for right triangles. Now, when we use the law of signs, we'll be able to use our trig, but we don't need to have a right triangle. So on the next slide, we have the formula that we're going to be using. And the formula for law of signs, it's right here. It's A over sine of A, B over sine of B, equals C over sine of C. Now, when we go to use this formula, we're not going to use all three ratios. We're only going to use them two at a time. And we're going to be solving these as if it were a proportion. So we could either do A over sine of A equals B over sine of B, or if we were given A and C, we would do A over sine of A, C over sine C, or B over sine B equals C over sine C. Now, if you recall back to your geometry days, we did triangle proofs. And our shortcuts that we used to prove triangles congruent were either side, 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 angle, side, angle, side, angle, or angle, angle, side, or hypotenuse leg. There were 5 shortcuts. However, for the law of sines and the law of cosines, we will not be using hypotenuse leg. So today, we're going to be looking at just a few of these. When we get to side, 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 and side, angle, side, that's going to be in the next section. That'll be the law of cosines. Now, we also have another one, and if you recall back from your geometry days, a lot of students thought that there was a shortcut called ASS or SSA. And we could not prove triangles congruent using either of these shortcuts. And what we're going to find when we're working with the law of signs, if we're given this type of information, it's going to produce an ambiguous case. And what's going to happen here is, based off of our given, we're either going to be able to find that there is one triangle. Now, all of these up here will always produce one triangle. But when we're given either A, angle, side, side, or side, side, angle, we're either going to end up getting one triangle out of that given information, 2 triangles, or no triangles at all. So, and the whole reason behind that is, if you recall that, and I know we've done a lot of this, that the sine of A, if I give you the sine of A equals 0.5, you should automatically know that sine of A, and think of 0.5 as 1/2, realize that that's going to be 30 degrees. Now remember, using our all students take calculus, also realize that there is also another angle that will also give us 1/2 when I do the inverse function here. So if I were to do 180 minus 30, the other angle in quadrant 2 would be 150. And this is why it's going to produce the ambiguous case, because we could actually end up with either an acute triangle or an obtuse triangle. And we're going to see this coming up. So again, when we're solving and using law of signs, today what we're going to be doing is we're going to be doing case 1 and case 2. Case 3 and 4, we're going to cover that in section 8.2, and we're going to be using the law of cosines. So the first case that we're going to cover is going to be case number 1. And this is going to be angle, angle, side, or side, angle, side. So notice I'm given 2 angle measures and a side length. And I've labeled my picture. And if you were to go around, you can see that you're coming here to an angle that was given, another angle, and then the side. So this is going to produce only one triangle. So let's go ahead and we're going to use our formula to find the missing pieces. Now, the easiest piece to find first is I'm going to find the measure of angle C. And the way that I can do that is I know that the 3 angles of a triangle add up to be 180. So I'm going to subtract the given 32 degrees and the given 81.8. Once I subtract those from 180, I find that my missing angle C is 66.2 degrees. So I can fill that in here. So now I have all 3 angles. Now I'm going to be using this formula, but again, remember, we're only going to take them 2 at a time. So let's go ahead and let's find, and again, we're going to be using our calculator. So again, remember, make sure your calculator is in degrees. So let's go ahead and take the side that was given to us, which is the 42.2. I'm going to put it over its angle, the sine of A, which is 32 degrees. And then I'm going to look for little b first. So little b over sine of B, which is 81.8. And now I'm going to go ahead and solve my proportion. I'm going to multiply sine of 32 times little b and 42.2 times sine of 81.8. So sine of 32 times b is equal to 42.2 times the sine of 81.8. I'm going to divide both sides by sine of 32. And then that'll leave me with b is equal to little b. And I'm going to do this in my calculator. So 42.2 times sine of 81.8 divided by sine of 32. And I get little b to be approximately equal to 80.1 centimeters. I can label the side of my triangle. Next, I need to find little c. I'm going to use my same given information. So I'm going to also use 42.2. I'm sorry, this should be a 42.9. So 42.9 over 42.9 over the sine of 32. I'm looking for little c, and the angle that it's across from is the 66.2. So now I'll again do the cross products. So sine of 32 times little c, and I'm going to set that equal to 42.9 times sine of 66.2. I need to get little c by itself, so I'm going to divide both sides by sine of 32. So again, take out your calculator. You'll multiply 42.9 times the sine of 66.2 and then divide it by sine of 32. And we'll find that little c is approximately equal to 74.1 centimeters. So again, when you're given an angle, and a side, or a side, angle, know that this will always produce only one triangle, and then you'll go ahead and plug it right into the formula. Let's try one more. Notice again, we're given an angle, and a side. And again, we've labeled everything in the picture. They gave us angle B and angle C. We can go ahead and find angle A by subtracting, taking 180, subtracting the 69.38 and the 74.08. Once I subtract those, angle A is 36.54 degrees. And now I can use my formula. I'm going to go ahead and use the sides that were given. So I'm going to do the sine of C. So I'm going to do 45.38 over the sine of C, and angle C is 74.08. I'm going to look for little b first. So b over the sine of 69.38. Again, I'm going to use my cross products here. Multiply that, and then that. So first, sine 74.08 times little b is equal to 45.38 times the sine of 69.38. Divide both sides by the sine of 74.08. Again, take out your calculator, and little b, after I multiply 45.38 times the sine of 69.38, divide by sine of 74.08, and little b is approximately equal to 44.17 meters. Now I have to find little a. Again, I'm always going back to my given. So I'm taking my 45.38 over the sine of 74.08, set that equal to little a over the sine of 36.54. Again, cross multiply. And divide. So sine of 74.08 times little a is equal to 45.38 times the sine of 36.54. Divide both sides by the sine of 74.08. And little a is approximately equal to 28.096 meters. I could round it to 28.1. And then there is my one triangle. Now we're going to cover the ambiguous case. Actually, not yet. We're going to cover angle, side, angle, which is still case 1. So again, my picture is labeled. I'm given angle A, which is 18.75. I'm given little c, which is 2,798, and angle B, which is 51.53. So let's find angle C first. That's the easiest one to do. So we'll do 180 minus 18.75 and minus 51.53. And that'll give me 109.72 degrees. And that's angle C. So again, we're going to use our proportion. We're going to use the 2,798 over the sine of angle C, which we just calculated. And now what we'll do is we're going to find little b. So little b over the sine of the angle across, which is the 51.53. Again, we're going to cross multiply. So sine of 109.72 times b equals 2,798 times the sine of 51.53. Divide both sides by the sine of 109.72. Little b is approximately equal to 2,327.12. Now we need to find little a. Again, I'm still going to use the 2,798 over the sine of 109.72. Now I'm looking for little a. The angle across from little a was the 1875. Cross multiply and divide. So the sine of 109.72 times little a is equal to 2,798 times the sine of 1875. Divide both sides by sine of 109.72. 109.72. And little a is approximately equal to 955.4 yards. These were also yards. So again, this case only produces one triangle. It is not the ambiguous case. Now we'll talk about the ambiguous case. The first, when we're dealing with the ambiguous case, we can either end up with either one triangle, two triangles, or no triangles. Again, your given information is either going to be side angle, or ASS. So again, this is either going to give us 0, 1, or 2 triangles. So let's go ahead and start solving this. When I have the ambiguous case, I'm going to solve for C first. So here what I need to do is go ahead and label. I need to put in here angle A, 43.5. I've already labeled little a and little c. So let's go ahead and find angle C first. So again, I'm going to set up my given, which is little a and angle A. So 10.7 over the sine of 43.5. I'm going to set that equal to 7.2 over the sine of C. Again, I'm going to cross multiply and divide. Sine of C times 10.7 is equal to sine of 43.5 times 7.2. Divide both sides by 10.7. And sine of C is equal to, I'll multiply sine 43.5 times 7.2, divide by 10.7, and I get 0.463. Now, first glance, you're going to say, okay, sine has to be a fraction. It has to be a number between -1 and +1. So this is going to work. So again, remember, when we're looking for an angle measure, we're going to do sine -1, 0.463, and angle C is going to be 27.6. So angle C is 27.6. Now, again, what we need to do is we need to check it to see if possibly there's a second triangle. So you can either stop and check it now to see if you have to do another one, or let's just go ahead and finish solving this first. So this angle C is 27.6. Now what I need to do is find little b. So what I'm going to do is take my information. So let's go ahead and find angle B first. So what I can do is take 180, subtract 43.5 and 27.6, and I can get the measurement of angle B, and it's going to be 108.9. So angle B is 108.9 degrees. Now I need to find lowercase b. So now I'm going to take my original, my 110.7 over the sine of 43.5, and now I'm going to do little b over the sine of 108.9, cross multiply and divide. So sine of 43.5 times little b is equal to 10.7 times the sine of 108.9. Divide both sides by sine of 43.5. And little b is approximately equal to 14.7. Now, again, because this is the scenario of side-side angle or angle side-side, I need to go back to this step here to see if possibly it could have created another triangle. So what I'm going to do is I need to see if I take 180 and if I subtract the 27.6, I'm going to get 180 152.4. I need to add my original angle to see if it's going to stay under, if I could form a triangle. So what I need to do is add 43.5, and you can see that it's going to be way too big. So this would not form a second triangle. So my only answers here are going to be angle C is 27.6, angle B is 108.9 degrees, and then I found little b to be 14.7 because I was given little a, it was 10.7, and I was given little c from the beginning. So now I also was given angle A. So I have all three angles and all three sides. So this ambiguous case only gave me one triangle. Next, we're going to do another ambiguous case, another scenario, because I'm given ASS or SSA, and then this one is going to result in no triangles formed. So again, if you go around the sides of your triangle, this is a side, and then we're given an angle. So side, side angle, or ASS. So again, when you're given these three pieces of information, the result is either going to be no triangles at all, one triangle, which was the scenario of the previous example, or two triangles. So let's go ahead and let's see what we can find out. So the first thing I'm going to do is take my 25.1 over my angle, which will be sine of A, and I'm going to go ahead and change these minutes, and I'm going to make it into the decimal degree for you. So I'm going to actually change the problem, and it's going to be 55.67. So angle B is 55.67. So that's what I'm using, 8.94 over the sine of 55.67. Now, if you're given a problem where you're given degrees and minutes, you will have to convert those by dividing it by 60 and making it a decimal degree. So now that I've set up my proportion, I can cross multiply. So the sine of A times 8.94 is equal to 25.1 times the sine of 55.67. I'm going to divide both sides by 8.94. And the sine of A is equal to, once I multiply and divide, 2.3184. Right away, this should be a red flag, because if you recall, sine cannot be a number that's greater than 1. But let's go ahead and do it on our calculator. Again, I'm looking for an angle measure, so I'm going to do the inverse. So 2.3184. Once I hit enter, I get error on my calculator. So as soon as I see that, I can stop and say that no triangle could be formed. So this is the easiest scenario. As soon as you get error on your calculator, and again, this should have been a red flag. Know that there is no angle when you do sine. That will give you an angle measure, and it wouldn't give you anything when this number is greater than 1. Now let's do the two triangles. Again, still the ambiguous case. So again, I'm given an angle, a side, and a side. If you wanted to go the other way, side, side, angle. So again, this will either produce either no triangles, 1, or 2. And we don't know which one of these it's going to be until we actually do the problem. So this is going to be our two triangle case. Again, you will not be told ahead of time which case you're dealing with. You'll have to figure it out. So let's go ahead and use our given information. So I'm going to do the 22.8 over the sine of 55.3. And then I'm going to look for little b first. So b over the sine of b. My little b was 24.9. Let me take that little b out of there. So 24.9 over the sine of b. Again, we're going to cross multiply. So the sine of b times 22.8 is equal to the sine of 55.3 times 24.9. Divide both sides by 22.8. And the sine of b, after I multiply and divide, I get 0.897. So again, you should realize that this will work. So again, sine, we're doing the inverse. So angle B is 63.9 degrees. Remember, this is the angle in quadrant 1. Remember, sine is also positive in quadrant 2. So I can also get an obtuse angle. But let's go ahead and finish the problem, and then we'll go back and see if we could find a second triangle. So let's finish it up. So this is the measure of angle B, 63.9 degrees. So I can label that in my picture. I can find angle C by subtracting. So 180 minus 63.9 and the 55.3 that was given to me. And then I can find out that angle C is equal to 60.8. Now I need to find side little c. So again, I'm going to use my given, 22.8 over the sine of 55.3 is equal to little c over the sine of 60.8. Cross multiply and divide. And then 22.8 times the sine of 60.8. Divide both sides by the sine of 55.3. Little c is approximately equal to 24.2. This is the first triangle. This is triangle number 1. Now, let's go back to where we first calculated angle B. And let's see if a second triangle exists. So what I need to do is I take the 180 and I'm going to subtract the 63.9 and let's subtract that, and I get 116.1. And now I also take that 116 and I'm going to add it to the 55.3. And I get 171.4. Notice that number stayed under 180. So this tells me that there is a second triangle. So I'm going to go ahead and subtract 180 minus the 171.4, and I find out that what remains for angle C is 8.6. Now, what I calculated, so little a and little b are still the same, but little c is going to change because I now have a new angle C. So I'm going to again take my original given, 22.8 over the sine of 55.3 is equal to little c over the sine of 8.6. Cross multiply. (22.8) times the sine of 8.6. Divide both sides by sine of 55.3. And little c is approximately equal to 4.15. So the two triangles, the first one is what I calculated over here. So my first triangle, angle A is 55.3 degrees. Angle B was also calculated, and that was 63.9. And angle C is 60.8. And then little a was given to me, 22.8 feet. Little b was given. And little c for this triangle is 24.2. So that is the first triangle. The second triangle, again, angle A was given 55.3 degrees. Angle B, we now have calculated angle C. So our new angle C is 8.6 degrees. And our new angle B here was 116.1. And then little a is the same. Little b is the same. And we have a new little c. And that one was 4.15. And again, these are feet. And the angles are all in degrees. So this is the ambiguous case where we could actually get two triangles. So again, this is just a screenshot from your textbook talking about the ambiguous case. Your homework is page 697, and you're completing numbers 27 through 39. So now, in addition to completing the homework, you have an assignment where you'll turn in the homework, and you also have an assignment where you need to turn in your completed notes. So for section 8.1, you have two assignments. One is to turn in the completed notes, and the other one is to complete this homework assignment. So work on your homework and the notes. They're due on Wednesday. And then if you find that you have any questions, please email me and I will get back to you and I will explain how to do the problem.